Probably the one that gets done wrong the most in this chapter, okay? I don't say that to freak you out. I say that to get you to pay attention because it really isn't a terribly difficult concept. It's more just remembering what the formula is supposed to do and doing it. So pay attention, make sure you got it. If you don't, ask me. We're going to start with a new term that you have not seen, at least I don't think you've seen. You haven't seen it from me, called a secant. Okay, we've talked about chords, we've talked about tangents. Now we're going to talk about a secant. A secant is kind of like a chord that keeps going through the circle. So if you take a chord and extend it, it's a line, right? Lines keep going. That intersects a circle. How many points does a chord intersect a circle at? 2. Okay, same thing for a secant. It intersects a circle at 2 points. So here's a point here, here's a point here. Line AB is a secant. Okay, it just keeps going through the circle. So you're going to see a lot of secants in today's lesson, but you're going to be using those secants to work with angles and arcs. Okay, so no side lengths. Everything's going to be a certain number of degrees. Arcs are degrees, angles are degrees. You're going to be working in degrees today, okay? So there are 2 different theorems here. They look very similar. What you need to notice is in this first picture, so this one versus these 3, right? Those 3 are all the same formula. They look a little different, but they all use the same formula. The top one, notice your 2 secants versus your 2 secants down here. What's the difference in the top versus the bottom 3? Bella?
The top they're like opposite of each other, and then in the bottom they're like next to each other. Or no, they like there's a center in the middle, like they intersect in the middle.
They intersect in the circle. That's what I'm looking for. Okay. So in that first picture, your point of intersection is inside the circle. Okay. Notice this one, they intersect outside the circle. Different formulas for those 2 different things, okay? So if it's inside the circle, here's the formula. Write this down. You're going to say the measure of the angle inside. So that could be this angle. It could also be this angle, right? They're the same measure. They're vertical angles. Doesn't matter which one you're talking about. They will be the same because they're vertical angles. But the measure of that angle, notice it's not a central. Your center of your circle is probably somewhere like here. That is not the center, okay? So it's not saying angle 1 is X degrees. If it was a central angle, that's what it would be. No, this is just saying here's a secant and another secant. They meet inside the circle. And when they meet, you will get half of the sum of the intercepted arc. So here's one intercepted arc, which is X. Here's the other intercepted arc, which is Y. So you go X plus Y, add those 2 arcs together, and then cut it in half, and it will equal the angle. Okay, so angle 1 is half of X plus Y. Or you could think of it as the angle is half of the one arc plus the other arc. Okay, so the angle is going to be the one that stands alone. The arcs always stay together. Okay? The other formula, when it's outside the circle, is also very similar. The only difference is you subtract instead of adding, but otherwise it's the same formula. So you'll notice now the angle is outside the circle, angle 1, angle 1, angle 1, right? So we're going to say angle 1 is half of, now it's always the arc that's farther away, which will also be the bigger arc. Okay, we don't want negative, so if you get a negative, it just means you subtracted your arcs in the wrong order. But it's going to be the bigger arc or the farther arc minus the closer arc, which is going to be the smaller arc. Okay, so you can think of it like that, or you can think of it as the angle equals half of the bigger arc minus the smaller arc. Or like I said, you could do the angle equals half of the farther minus the closer. However you want to think of it, both of those will always work, okay? But just keep in mind, again, your arcs stay together. Your angle is the standalone, okay? Angles by itself, arcs are together. And just notice what this looks like. So these are tangent. right? This third picture. But it's the same thing as if one's tangent and one is a secant, or if both are secants, both go through the circle, you do the exact same thing every single time. Any questions on the formulas? Okay, biggest thing to look out for is it does not have to be that your variables are together. It has to be that your arcs are together, right? Angle is by itself, arcs are together. A lot of people mess that up. They just put the variable as the thing that's by itself, and that's not the case, okay? So let's take a look at this. So this first one here, okay, notice where your point of intersection is. Are you going to add or subtract on this one? You're going to add because it's inside, okay? So when the point meets inside the circle, we know we're adding. Keep in mind it's the angle equals half of the arc plus the arc. So what goes here? X. The angle right now is your unknown, so that's going to be X equals half of what? 46 plus 90. And at that point, you can just plug it into your calculator if you want. 1/2 parenthesis 46 plus 90. Don't just take half of 46, half of the whole thing, right? You should get X equals, sorry, too much junk here. What does that come out to? 68, half of 136. So 68 degrees. Questions on that? You want to try letter B on your own? I'll give it a go. Give it a go. Try it. Ask yourself, am I going to add or subtract? Which one's the angle? That should be by itself. What are the arcs? Those should be together. How would you set that up? Actually, just do that. Set it up. Something equals half of something plus or minus something. You don't even have to do all the solving. I'll help you with the algebra, but I just want to see if you can set it up right. All right, how did you set it up? What's your standalone? 20. Okay, so 20 equals, angle equals, then what?
1/2, 95 minus.
Right, so the farther arc or the bigger arc, it's always the one that's further away first. So 95 minus your variable, the z, and that will be your setup. Okay, now here's the deal. A lot of people love to distribute, and I get that. Distributing is great. However, if you distribute right now, you get a decimal and then a fraction with your variable, which is just ugly. Anyone see a nicer way that you could solve this without distributing? Multiply by 2. If I were you, that's what I would do. It's not wrong to do it the other way, but people do it wrong a lot when they do it the other way. So I would right now just multiply by 2, and that's going to get rid of your 1/2. So you get 40 equals 95 minus z. From here you have options. What would you do next? Put z on the other side. Okay, so subtract, move z over to make it positive. Okay, and then get rid of the 40 over there. So z is 55 degrees. Okay, and you can always double check it by just plugging it back into what you started with. 1/2 of 95 minus 55 is half of 40, which is 20, which makes sense with how you had it set up. Questions on that? Okay, example 2 gets a little bit fancier because it feels like there's not enough information. Look at what it says. You're going to solve for x. It says assume lines that appear to be tangent are tangent to the circle. So here's a point of tangency, and here is a point of tangency. The idea is, first of all, are you adding or subtracting on this one? Subtracting, because it meets outside the circle, okay? So what is your standalone?
40.
The 40. So 40 is going to equal half of the bigger arc minus the smaller arc.
I thought it was farther and closer.
Sure, it
Oh,
is.
is that-
Farther and closer, bigger and smaller, they'll always be the same thing.
Oh, it's the same.
Yeah, bigger will always be the one that's further away. Smaller will always be the one that's closer. Thanks,
So
Brooke.
X would be the smaller.
X is the smaller. So that means that one's going to go here, right? X is going to go there. But what is this arc?
180.
It's not 180. They don't tell us that. In fact, it can't be 180
Wait, no, it's 80.
when it's tangent.
It's 80.
It's not 80, but I know what you did there. You took the 40 and you doubled it, right? When do we get to double an angle like that? The inscribed, when it's on the circle. This one's not on the circle. This one's outside the circle.
Oh, so it's 2X.
Luke,
This is 140.
it's not 140. You can't give me an actual number right now.
It's 2X.
It's not 2x.
X squared.
Nope. But it does involve x. If you have a circle, yeah, Audrey.
360 minus X?
That's the one. A circle is 360, right? And this is not half, part of the circle. And the other part would have to add up to 360 with that x, right? So this part is 360 minus whatever x is. That keeps one variable for us, which is super helpful. So you would put the bigger or the farther arc, 360 minus x, and then subtract x. Does that make sense? Bigger arc minus smaller arc. Okay, now let's simplify that. You get, you know what, I'm gonna bring it over here. Okay, so if this is our setup, this would be 40 equals half of 360, what?
Minus 2x.
Minus 2x. Minus x is minus 2x. Okay? What's your next step? Multiply by 2. Now, this one would be way easier to distribute because you have a 2x there. So if you want to distribute it, go ahead and distribute it. I'm going to multiply by 2 just to try to get you in that habit. So if I multiply by 2 here, then I got to multiply by 2 here. So 80 equals 360 minus 2x. Move the 2x over to the other side. Move the 80 over to this side. So you get 2x equals, what is that? 280. Is that right? My mental math right now. Yeah. Divide by 2. So x is 140. Okay. That means if we're looking at this right here is 140, which would mean 360 minus 140 would have to make this 220 for the measure of that arc. Luke.
So it says both of them are tangent. So can you technically create that? So you could do 40 plus 90 plus 90 and all of that minus 360 because they're both tangent. So that would create.
It would
360.
find, right. So if you wanted to set it up this way, where
Yeah,
this
so-
is 90 and 90,
So you
then you'd
find
find that
X.
angle, which will be the same as that arc.
Yeah.
Mhm.
And then you could do 360 minus 140.
Well, you don't even have to find that.
Oh, yeah.
You just had to find x,
Yeah.
right? But yes, so you could technically set it up like that and get there the same. Yeah. Questions on that?
Wait, for
Okay.
example A, how is that not like the inscribed angle? Because couldn't X be 45 then?
No, the inscribed angle has to be on the circle. So your vertex would be here, right? If it was there, that would be 45. But when it's inside the circle, then you have to do half of the sum of your arcs. Yeah. This is why this part gets really tricky because you've seen a lot of different types of angles, right? You've seen on the circle, you've seen inside, you've seen outside. It just gets a little involved. Questions on any of that? Short and sweet, right? Okay, real quick. I'm going to draw you 3 pictures and you tell me if you would add or subtract. That's all I want to know. Actually, maybe that's not all I want to know. You don't need to write this down. I just want you trying it out. Let's say this is x this is one, that's not what I want. This is 115 and this is 160. How would you set that up? Are you gonna add or subtract? You're gonna add. What's the standalone? 115. So 115 equals half of 160 plus x, right? Inside we add. The standalone is always the angle. Okay? One more, and then I'll leave you alone. Let's say you have this, and this is x. It's terrible, sorry. We'll say this is 150, and this is, we'll call it 80. Okay, so here's your picture. Are you gonna add or subtract?
Subtract.
You're gonna subtract because the angle's outside, and what is your standalone? 150, 80, or x? X. The angle's always the standalone. So x equals half of what?
150 minus 80.
Right, bigger minus smaller, or farther away minus closer to the angle. Okay? Okay. That is all. 12.4a.